Good morning, Cyber Warriors. What do you think we have in store for us today? It's time to talk about file attributes and how to get all of the stuff together, put them together in a nice little package, and dump them out for our investigators. Whether we're doing the investigation ourselves or we're passing it over to our Tier 1 or Tier 2 analysts to conduct a forensic investigation of a computer system. How about we get right to it? When conducting a forensic investigation, you need to collect a lot of different artifacts about a file, maybe multiple files all at the same time. And there are a number of ways to do that, many of which you can do directly through the GUI, but some things you have to do through command line or through third-party tools, such as getting a hash value. There is no way to generate a hash value directly natively through the graphic user interface in Microsoft Windows. Or if there is, I've not been made aware of it, but I will show you two different ways to get a hash value for these files. But knowing right now, the only way to do that is to upload the file to some third-party web like VirusTotal or something along those lines, and it'll provide those hash values and file size and all kinds of good information for you. But for this purpose, I'm just going to go through the graphic side right now, and then we'll step into using Command Prompt and then also the PowerShell so that we can collect all of this information. Okay, so just simply clicking on a file in the Windows Explorer, yes, I said Explorer, will provide just the basic information, right? You have the file name. You have to actually turn on the file extensions to see those. I recommend always doing that. That way you don't get fooled by something that is .txt, .exe, which unfortunately still is a common problem. But if you select this, if you hover over it, you have a little bit of information here. It tells you the date modified, the file size, and the fact it's a rich text document type. Down here, it will also tell you the number of bytes, but really it's limited what you can get from there. You have to go down, right-click, get the properties. From here, you get the file path, which we already knew the path, but it gives you the definitive path. The file size, the size on disk, which is based off of stuff I'm not getting into today. You have 3 different timestamps: your created timestamp, modified, and accessed. So you'll see that it was created on Thursday, January 12th, which happens to be yesterday because today is Friday the 13th. Ooh. But it was modified Wednesday, December 21st, 2022. So how does something get modified after it's created? It's a really good question. And that's because the file was moved from where it was to where it currently is. So this file was moved yesterday into this folder. It existed in a different folder previously. So that's how it actually came to be like that. And it's just knowing that provides a little extra information for you. And then go down into here in the system tab, security tab, we have information about the file owner and what security properties they have. This is better displayed here for the owner and what computer this belongs to, along with the date created, date modified as well. Previous versions, this will work for some executables, but generally not a file like a text file, rich text format, something along those lines. So I don't generally look into the previous versions tab unless it is an exe. But that's it. That's all you can get out of here. But a lot of times you need to have the hash value. And what is a hash value? Well, a hash value is a supposedly non-reversible calculation of what that file is. So I'm going to just open up Command Prompt real fast. And we're going to get the hash value for our forensics Question.rtf. And in order to do that, you have to use a utility called certutil. Certutil. Okay, and that's the program, no space in that name there. And then we need to tell it what to do, and we're going to hash file. And we want, and this is in quotes because we have a space, forensics question. And then we have the algorithm, and we're going to do MD5. So there you have it. And we could also do SHA-256. You have to know what these different algorithms are in order to run the certutil to hash them. Now, what if you want to have, and you need to have, both the MD5 and the SHA-256 all in one fell swoop? Can you put them together? Well, let's find out. MD5, comma. Nope. It doesn't like that. You can't do it. You have to do them each individually, which, let's be honest, kind of sucks. But only a lot. So let's kind of minimize this for right now, because now that is basically how you would get that information. And let's instead go into PowerShell. Okay, so in PowerShell, you have the command Get-FileHash, and then you want to go through the algorithm, and this is great because you can just go through the different algorithms by tab. Just hit tab and it'll go right through all of them. Unfortunately, just like the certutil, and we're going to do .forensics. So just like certutil, you can't do multiple at the same time. It'll give an error. So you have to do this one at a time as well, but you kind of don't. There's a way to keep doing this iteratively with the PowerShell pipeline, and I'm going to show you how to do that right now. So first thing we want to do is we want to create a variable with our forensics question. Wow. Hang on, I need more coffee. That should do it. All right. So we're going to create a variable called attributes. And this is going to be Get-ChildItem. Forensics question. Okay. So now we can do some information and find out what is available directly from that piece of information. So attributes, use tab to autocomplete. We're going to pipe that to get member. And we're going to look at the member type. And this is proper. Yeah, let's do property. So we have a slew of information here that we're going to be able to use, and we want to take a look at. Some specific ones are anything time related, right? So create time, and there's a create time UTC. Last access time UTC, last write time, and last write time UTC. Last write time is the same as modified time. So creation obviously is with the creation time. Last access is obviously the last time that file was touched by somebody. And doesn't necessarily mean opened. If they looked at it like bringing up the properties, so when we did the right click and properties, we changed that last access time because we accessed information about that file. So it doesn't necessarily mean that it was last time it was opened, but it does generally give you a good idea of when it was last opened, because how often do you go up and get the properties tab on the file? Normally you just open files, right? Most people just open files. They rarely look at the guts of the file like that we did here. So there's length, which is the file size. We have name and base name. So let's take a look at a couple of these pieces of information. So we're going to grab this and we're going to change it from get member to select object. And we're going to look at some of these properties just individually, right? So I want to do creation time first. Okay. So here we have two different timestamps, creation time and creation time UTC, and you notice that they're different. UTC is Universal Time Code or Corridor. It goes through Greenwich, England. It is the prime meridian. And when you look at a globe and it has all of those up and down stripes, little pizza pie slices that it creates of the globe, those are the meridians. The ones that go around like a belt, those are the latitudes. Like a ladder is how I was taught how to keep track of that when I was in elementary school. So I live in Arizona, so I am always 7 hours off of UTC. So I always know what my time is in relation to the UTC. And why UTC is being used for people, especially in the cybersecurity business, is because a lot of times we have our company or our customers that we support have things in multiple different time zones. And a lot of times when you're looking at an alert from like your SIEM solution or something along those lines, you get an alert or a notification, hey, this happened at this time. Well, what time did it happen? Did it happen in my time zone? Did it happen in the time zone where that system was? Did it happen in UTC? Because a lot of the systems are kept on UTC in order to normalize everything. So you have to kind of have an understanding of which time zone you're talking about. This creation time in this instance actually happens to be from the Phoenix time zone because we don't change with daylight savings. We are always 7 hours from UTC. But bringing all of that back together, the most important time is actually the time for the UTC. So when you're collecting or you're going to be reporting objects about time, you generally want to do it this way, where it is time UTC. It has to have the asterisk. So that way you have the creation time, last access time, and last write time. And that gives it in a normalized way so that you can actually tell what they are. And you want to have those in a way you can capture it and report it. A lot of times you're going to be doing an investigation. You're going to collect information and artifacts from the system. You're going to put it into another file that you can review over and over and over later on another system. And for our purposes, at the end of this, we're going to output into a CSV file, and that way we can access it that way. And I'll talk about the exporting and importing will be my next video. But enough about the time stuff. I can go on about it forever. You actually want to collect all of the time stuff just because. So that way you have all of these bits of information here so that you can report it all. It's helpful to have the system time so you can reconcile that against the UTC, and you can tell, doing simple math, that there is a 7-hour difference between them. So that way you realize, hey, this person or this computer system exists at, UTC -7. I think that's the way. I can't do that math in my head sometimes. But there you have it. So let's take a look at some of the other properties. And we're going to want to look at the base name, and the full name, right? So we want to have star name, right? But we don't necessarily want to have directory name, and we don't want to have the PS child name. So we're going to have to actually kind of do this a little bit more intelligently, which unfortunately means it's going to be a little bit more wordy. I generally put it in this order. Oop. I don't want it in a table. I want it format custom hex list. There you go. That's the one. So base name, the regular name, and then the full name, right? So we're adding a little bit of information to each one. You have the base name, which does not include the extension. You have the name, which does include the extension, and the full name includes the whole full path to the file. So I like to collect all three of those in that order. It doesn't have to be in that order. I just like to order it that way. So that's kind of where I want to go with all of that stuff. So those are the things we want to do. Is we want to collect time, and length. So let's look at length. It's important to know the file size, because if you have files of certain sizes, certain hash values like MD5, you can have what's called collisions, where you have the files may be different, but they have the same hash value because of circumstances. And if you have a file size that is 17 bytes or smaller, the chance of collision goes up radically. I don't know the math. I don't understand the math behind it, but that's something I've encountered in the real world, where I had the same hash value for 3 different files on one system, and all 3 were different file sizes. So that was confusing, because it was being reported as this one thing, when in fact all 3 files were completely different than the thing it was being reported as. So it's just something to understand and be aware of. Okay, so now we want to take a look at the hash values for these, right? So before we were taking a look at just the different objects in that, but now we're going to look at attributes, and we're going to push it to Get-FileHash, right? Because we need to get the hash value. So the first one is the MD5. And so now that we know that, it's good to know. However, we also need to have, let's take a look at all of the stuff that is available there, right? So get member, and then member type, and we're going to look at properties. So there's really not a lot associated with this, right? We have the algorithm, which we already knew, which is this, which is MD5, the hash, and the path. But that doesn't include the length. It doesn't include the timestamp. It doesn't include a lot of the other information which we get from Get-ChildItem. So we have to take the information from Get-ChildItem and enrich it with the information from Get-FileHash. And SHA 256. Good. So we need to collect that, and we need to collect the other one. So how do we do those? And it's the same as we did with enriching anything else, right? So we have to do an expression where we're looking for those different elements. And this is kind of, it'll be a little long to begin with, but I'm going to show you kind of a better way to do that. Okay. So just going to, as proof of concept, we're going to attributes. We're going to select object, and we talked about the different properties we want. Let's do the name objects first, right? So base name, name, full name, length, and then we want time, because we can get all those times all at once, right? So let's just take a look at what this looks like first. Okay, so we have all of that stuff. Good, excellent. We're going to be able to do stuff with this. Now we need to add our hash values, right? So we want to go up, and we're going to do a comma and then at curly brace name equals MD5. We're going to give it the algorithm name that we're going to use at this point, and semicolon, and I'm just going to do a carriage return to the next line so we can see it. Expression equals, and our expression is going to be Get-FileHash. The algorithm is going to be MD5. And this is going to be from our file, right? So this is, and we have to do full name. No tab complete for that, unfortunately. And actually, technically, I should do path here first. This is better programmatically. All right, so now we end that particular piece, but all we need is this portion, right? So we're going to get just a hash and two curly braces. Actually, yes, two curly braces to end it. And let's just take a look at that real fast. And now we've added the MD5 hash. So let's actually go up and add our SHA-256. So it's going to be almost exactly the same, right? So we have a comma. I'm going to grab this because I am way too lazy to type all of that stuff. And we're just going to go ahead and paste all of that. Go back here and change our algorithm. SHA-1, SHA-256. There we go. And we're going to test it. Oh, I forgot to change the name. Have to always change both. SHA-256. There we go. That's more like it. This is the stuff we need to see. This is the basic information we're looking for as part of a forensic investigation of a system for a particular file. It gives us the base name, the full name plus the path, the length of the file, all of the timestamps associated with it, and the MD5 or the hashes that are generally collected. You can do a whole bunch more hashes, but generally only two different hashes are collected. And that's the MD5 value and the SHA-256. MD5 is because it is the oldest standard. It's what we've been using the longest. People still report artifacts in MD5 hashes. There are problems with it. You can create collisions deliberately. So it's not very reliable. It's pretty reliable, but there's not an absolute with it. Even SHA-256 is going to be questionable now that quantum computing is on the horizon, but that's a whole other story. So I told you that we were going to take this and we were going to put it into a you want to expand this beyond just one single file. So let's go all the way to the beginning, and instead of doing from our variable, we're going to do Get-ChildItem, Recurse, and file. All right, so what this command does is it gets the basic information about every file that is inside that folder and all of the subsequent folders inside it. So if I had multiple folders with multiple files, it would collect all of that. As of right now, I don't, but I do have 3 files in there, so I should have 3 results when I get to the end of all of this. And boom, now I have 3 files, 3 results. Okay. Now, technically, I could also go in and take a look and see if there are any streams for any of that stuff for ADS. Not going to go into that right now. But you want to make this portable. You want to make it so that you can dump it over to another system to actually do your investigation work. In order to do that, generally, a lot of times we push things into a CSV file. So there is a lovely command, Export-Csv. Now there's only one thing you really have to do with this, and that is to give it a you have to give it a path, which the path is actually just the file name or the path you want to keep it in. So that's something you have to do. So I'm going to do the path. And I want to put it on the desktop. And we're going to call this file-details.csv. Now, why do you want to push this into a different folder? You want to push it into a different folder because otherwise you're going to collect information on the file itself that you're trying to investigate. So you always push this to, when you're doing Get-ChildItem, you always want to make sure your export goes into a different folder. Or you could just simply push it into a variable and then use that variable later to push it into. That's probably a better practice, but I'm already here, so let's just keep going. There is a second thing I like to do, and it is -NoTypeInformation. So you saw no clobber on there. That just means it won't overwrite. It'll force you to go, nah, that file exists. You probably want to rename it. But NoTypeInformation prevents it from putting a header inside your CSV that you really don't want or need. And there it is. Boom. And you see right here, file details. And we're going to open it with Notepad. So all of these elements here are part of our header line, and we have the 3 different files. So you've got the base name, and then the name, and then the full name in here, the length, and the different date stamps. Then scrolling along, we have our MD5 and our SHA-256. So that provides all the information in there. Now, if you're going to do it and you have hundreds or if not thousands of files, it allows you to take all of this stuff out and then do your investigation much later. All right. Alrighty then, Cyber Warriors. Covered a lot of stuff. It was a long video this time around, about a half hour or so. So there's a ton of stuff. Collecting all the information, being able to enrich it into the PowerShell with the PowerShell pipeline, and then taking that and dumping it right into a CSV so that our analysts can take a look at that system. There's a lot of stuff. Really good stuff. As per always, I hope you learned something. Hope you had fun. Happy hunting. And I'll see you in the next video.